Good day, viewers. So this is going to be the last part of uh, upthrust density. So we want to look at the principle of flotation. Now, what does the principle of flotation say? The principle of flotation says that a floating object displaces its own weight of the fluid in which it floats. I know the definition may sound somehow, but in simpler terms, what the principle of flotation is saying is that when an object floats in a fluid, the weight of the fluid displaced is equal to the weight of the object. The weight of the fluid displaced will be equal to the weight of the whole object. It doesn't matter whether uh, a very big fraction of the object is immersed in the fluid. No matter what fraction is immersed, because when we say something is floating, it may be that a fractional part of the object is inside the fluid while the other part is outside on the surface. All right. So what this principle is saying is that when an object is floating in a fluid, the weight of the object is equal to the weight of the fluid displaced. So it displaces its own weight of the fluid in which it floats. Now it means we can write an equation for this. What this means is that weight of the whole object that is floating is equal to the upthrust on the object. Because what is upthrust? Upthrust is weight of the fluid itself. Upthrust is weight of fluid. Weight of fluid. Now, this principle now says it will displace its own weight of the fluid. So, meaning the weight of object is equal to the upthrust on the object. And don't forget, what is upthrust? Density of fluid times volume of object immersed times G, or times 0.01, depending on what the unit of density is and then the unit of volume. So we have some questions on the board. Let's tackle these two questions on the board. The first question says, a cylindrical piece of wood of mass 100 gram and uniform cross-sectional area 40 cm cube, 40 centimeters square, floats upright in water of density 1.0 gram per cm cube. What is the length of the wood immersed in water? Now, I want you to bear it at the back of your mind that anytime you hear float, whenever you hear float, you hear flotation, you hear floating, anything float at all, anytime you see a question on it, just write your equation out. W, weight of object that is floating, equals upthrust on what? On your object, all right? This equation is very important. Now, what are we given? We are given the mass of the wood. Mass of wood is 100 grams. So let's get the weight, because we need the weight of the object. This time around, the object is the wood. It means the weight of wood will be 100 over 100. That's 1 Newton. All right? And uniform cross-sectional area. So area, cross-sectional cross-sectional area is 40 centimeter square. So it's floating upright in water of density 1.0 gram. Density of water is 1.0 gram per cm cube. All right. What's the length of the wood immersed in water? Now, how do we get the length of the wood immersed in water? Let's get upthrust. Upthrust on wood equals density of water times volume of wood immersed, then times. Now, density is in gram per cm cube, volume is in cm cube, area is in centimeter square. So, well, volume is going to be in cm cube, then times 0.01. All right. If you can remember my first video, I did something like this. All right. So what's density? 1.0. Then what's the volume? Now, volume of any uniformly shaped object, like a cuboid, like a cube, cylinder, is going to be equal to the cross-sectional area times the length joining the two cross sections together. All right. So what's the volume? Volume is cross-sectional area times length now, times the length submerged or the length immersed, then times 0.01. So that upthrust is not going to be 0.4 L, 0.4 L, 0.4 times L. All right. Now we go back here. So this is the length we are looking for. This L here is the length we are looking for. It's the one we multiply by the cross-sectional area. So we go back to our formula. Weight is equal to upthrust. So what's our weight? 1. So 1 is equal to 0.4 L. Make L the solid of formula. Weight, our weight is 1, right? So I just substituted this one now here. So L is going to be equal to 1 over 0.4. And then length is going to be equal to, that's 2.5. 2.5 centimeter, meaning 2.5 centimeter of the length of that piece of wood is immersed in water. All right. And the next question says a plastic sphere floats in water with 50% of its volume submerged. If it floats in glycerin with 40% of its volume submerged, the density of the glycerin is what? All right. Now, no matter where an object is floating, because this also is principle of flotation, whether it is floating in air, floating in water, floating in paraffin, floating in kerosene or in petrol, whatever, the principle of flotation still holds. So if the plastic floats in water, what is the principle of flotation? It says the weight of the plastic is equal to what? Is equal to the upthrust in water. If it also floats in glycerin, what happens again? The weight of the object is still equal to the upthrust in glycerin. So see what I'm going to write? Weight of plastic equals upthrust in what? In water, which is also equal to upthrust in glycerin. Upthrust in glycerin, all right? So although we don't know the weight, but I can equate these two together. So what it means is that upthrust in water is equal to upthrust in glycerin. So what's the upthrust in water? Density of water times volume of object immersed times 0.01, then glycerin, density of glycerin times volume of object immersed in glycerin times 0.01. This one cancels out. You can decide to use G. It will also cancel out, but I'm using 0.01 because I intend to use gram per cm cube for the density of water. So what's the density of water? If you are not given, it's constant as far as it is pure water. If it is not seawater, So 1.0 gram per cm cube times. Now we are told that 50% of its volume. So let the whole volume, if the whole volume is V, the whole volume of the plastic sphere is V. So 50% of that is going to be 50 V over what? 100, which is 0.5 V. Then density of glycerin is unknown, then times 40% of the volume is submerged, okay? So that's 40 V over 100, all right? Now, this can cancel out. 50 V will be equal to 40. I think V can also cancel out now. V can take care of V. So that 50 equals to 40 times the density of the glycerin. And then make it density such the formula. 50 over 40. That's 5 over 4. And 5 over 4 is 1.25. 1.25. And this is going to be 1.25 grams per cm cube because I use gram per cm cube for water. So that is all about the principle of flotation. So please, you can like, comment, share with your friends, and subscribe. Thank you.